What another day. Today we get to do balancing of chemical reactions. Now this is one of the more fun things of chemistry, and this is going to be for the high school level chemistry. It gets to be a lot of fun when you get to oxidation and redox, but we're not going to do that for right now. So before you watch this video, I suggest you watch my video on ionic versus covalent bondings, as well as my ionic compounds and my videos on atoms. And so, without further ado, let's balance some reactions. Alright, I'd say let's start with something easy. Calcium chloride will react to form a calcium ion in aqueous solution plus a chlorine ion in aqueous solution. And so these suffixes you guys are going to start seeing a lot, and so I'm going to make a video soon just about them, but I'm just going to get you guys used to seeing them. So calcium chloride, now Ca has a 2+ charge. Refer to your periodic table to see that, and Cl has a -1 charge. So we cross the charges and get a 2 after the chlorine, so 2 chlorines to 1 calcium. Now, what we have to do on this side is put our charges in. Because calcium is by itself, we have to do the 2+ charge, and chlorine is by itself, so we have to do the minus charge. Now what we notice is the charges are not even on both sides. This whole side has a charge of 0. This whole side has a charge right now of a +1 charge. Or a 1+ charge, as it's more accurately said. And also, we have 2 chlorines on this side, and we have 1 chlorine on this side. So let's fix them both with one smooth stroke. I'm going to simply put a 2 there. Now what happens is we have 2 negative charges, 2+ charges, overall charge is 0, and we have 2 chlorines. Now, this is a balanced reaction, so I'm going to get rid of all this stuff so you can see the reaction. Oops, not the charge. The charge must stay. See it as a whole. This is a balanced reaction. Everything is the same on both sides of the reaction. Now let's move on to something a little bit more tricky. We'll have aluminum chloride plus hydrogen gas will react to form aluminum as a solid plus hydrochloride gas. Hydrogen chloride gas, aluminum, solid, and we have a 3 here because aluminum has a +3 charge. Now, with it in a solid state, it has no charge. And so, let's start by balancing the reaction. We are going to work our way this way. So start with the aluminum. The aluminums are the same on both sides. So that's easy. Chlorines are not the same. We have 3 chlorines on this side and 1 chlorine on this side, so I'm just going to multiply this by 3. Simple and nice. And oh no, now when we go to hydrogen, we have 2 hydrogens on this side, 3 on this side. So what I'm simply going to do is take this 3 and multiply it by 2, equaling 6. And so we're going to put a 3 over here. Now we have 6 hydrogens on this side, and when we change this 3 out for a 6, we have 6 hydrogens on this side. But guess what? Chlorine is also multiplied by 2. So now, well, also multiplied by 6. So now we have 6 chlorines on this side, 3 on this side. So I'm going to put a prefix of a 2 on this side. And now we have a different number of aluminums. We have 2 aluminums on this side, 1 on this side. So put a 2. Now did that seem like, ooh, did not want to do that. Now did that seem at all like complete chaos? Well, it probably did. But now look, we have 2 aluminums, 2 aluminums. 6 chlorines, 6 chlorines. 6 hydrogens, 6 hydrogens. Now that's kind of cool. And the overall charge of both sides, because aluminum's a solid, is 0. Now we're going to go over a basic writing of this of these charges. So we have compound A with compound B forming compound C plus compound D. Now let's say we had 2 compound A's, 4 compound B's, 6 compound C's, and 2 compound D's. Now here's a quick rule that I'm going to teach you. You want all of the prefixes to be the lowest possible number they can be. With these prefixes, we can divide everything by 2, in which case the reaction should be A plus 2B reacts to form 3C plus D. That is the simplest way that reaction can go. And so whenever this happens, try to find the lowest multiple. Now in our aluminum chloride reaction, we're already at our lowest common multiple because hydrogen is at a 3 and you can't divide that by anything. Except 1, but you still have 3. So now I'm going to go over an exception to that rule, called a combustion reaction. What I'm going to do is use butane, which is C4H10. And that, in all combustion reactions, reacts with oxygen gas. And that will form carbon dioxide plus water. And so water is a liquid, carbon dioxide is a gas, oxygen is a gas, and this is going to be a gas for this run. It could also be a liquid, doesn't particularly matter, but we're going to use it as a liquid, well, as a gas. So we have 4 carbons on this side, we have 1 carbon on this side, so we'll multiply it by 4. Now we have 10 hydrogens on this side, 2 on this side. So 2 times 5 equals 10. So we put the prefix 5. Now, I'm going to draw this O more clearly. We have 4 times 2, which is 8 oxygens, 5 times 1, so that's 5 oxygens. So that means we have a grand total of 13 oxygens on this side. But we have a 2 on this side as a suffix. With 2 as a suffix and 13 as the multiple that we should use, what should we do? Well, some would say we could just multiply the entire equation by 2, and so this is 26, and then this number becomes 8, and this number becomes 10. That is a balanced reaction, but here's a rule with combustion reactions. We want the organic molecule, or this molecule, whatever is being combusted. I don't know why, what just got deleted. Oh, my 0. We want this to have a prefix of 1, in which case oxygen is going to get a fraction in front of it. So that fraction that we are going to put in front of it will be 13 divided by 2. And so, with this, we have a fraction as a prefix. Now, I said earlier that we don't want a fraction as a prefix. However, combustion reactions are an exception to that. So just remember that, especially if you go into chemistry, high school or general chemistry class. The oxygens will have a fraction. Now you could write it slightly differently, such as you can figure out that, well, it's 6 1/2 oxygens. You can do that if you want. I just like the 13 over 2. But you can, in fact, do 16 1/2. So that is everything you would need to know for this level of balancing reactions. Remember to keep the charges the same and make sure all the elements are the same on both sides of the reaction. And that is pretty much all for right now. And I'm just going to have some more videos coming to you soon.